Breaking the wall of coal. How climate science calls for radical changes in energy policy. Ottmar Edenhofer, Potsdam Institute for Climate Impact Research.
On the 9th of November 1989, I was pondering Hegel's phenomenology of spirit.
So thank you very much. So last week, a paper has been published in Nature about the accessibility of the IPCC reports, and the result was that it is as complicated as Hegel's philosophical works. So basically what we can learn from this is there is no need to be accessible and understandable. You can have nevertheless an impact. So let me start about breaking the wall of coal. So the global community expects in Paris that the head of states come to an agreement about the global climate policy. But despite of the efforts to impose a climate policy in many countries, and despite of the financial crisis since 2008, we observe that the emissions are rising. And in the last decade, we even observe increasing emissions with an increasing growth rate. And it is important to understand why this is the case. It is the case because we are in the middle of the largest coal renaissance since the 50s. And I would like to explain you this a little bit more in detail. In this graph, we have decomposed the growth rate of emissions basically into a few components. One important component is population growth, and it is obvious that an increasing population might cause more emissions. The second and an even more important component is GDP per capita. So we have seen in the last few decades a remarkable increase in the GDP per capita, which is nice, it is good for the human well-being, but at the same time, we see increasing emissions. And then a third component, which is also a quite favorable outcome, we see a declining energy intensity. Or the other way around, an increasing energy efficiency. However, the increasing energy efficiency all the time has been overcompensated by population growth and economic growth. But now there is a fourth component. And this component is the carbon intensity. So in the last decade, we do no longer see a declining carbon intensity, which basically means the carbon content of our primary energy use. We see an increasing carbon intensity. Why was this the case? It was the case because we have seen a remarkable increase of the usage of coal, in particular in the power sector. The gas price has a higher growth rate than the coal price, and this triggers the additional use of coal in the power sector. So I do not deny the remarkable progress we have seen in the last decade in the renewable energy sector, in particular photovoltaics and the wind power. But nevertheless, despite of this progress, coal has overcompensated this effect in the deployment of renewables, but also in the deployment of nuclear power. Now you might say, this is history. It's part of the past, but now we are looking for a much brighter and a nicer future. Now I would like to explain you this is not the case. Worldwide, we have seen now plans to install 1,000 gigawatts coal-fired plants in the next 2 decades. 1,000 gigawatts. Admittedly, not all these plans will be successful. But even if only 1/3 of these plants will be successful, we will see, for an additional lifetime of a coal-fired plant between 40 to 50 years, we will see additional emissions of 120 gigatons CO2. If we add to this cumulative emissions, the emissions caused by the existing infrastructure, energy infrastructure, we can add additional 730 gigatons. And this number is very close to the magic number of the 1,000 gigatons CO2, which is consistent with the budget to achieve the 2-degree target, or to phrase it a little bit better, to limit the increase of global mean temperature to 2 degrees. And why this was the case? This is what we economists call the power of the relative prices. Coal is cheap, it is abundant around the globe. And what we can see is the deployment of coal no longer depends on the domestic endowment, because the coal market becomes more and more globalized, and therefore relative price of coal is essential. Now look at this graph here, and I apologize again, in the IPCC we have some reputation to produce non-accessible graphs, but nevertheless this is a quite useful one. You can here see the non-Annex 1 countries. This is IPCC lingo, which basically means the developing countries. And you can see here that the empirical data are even worse than our worst case scenarios. We are already beyond the scenarios in the usage of coal, in particular in the developing countries. Now let me say a few words where we should be. So the global community argues it might be a good idea to limit the increase of global mean temperature around 2 degrees. Is the 2-degree target a reasonable goal? There are many reasons why people argue for a 2-degree target or for a 2-degree limit. So, for example, the increasing risk of sea level rise, the dieback of the Amazonian forest, and so on. But from my point of view, it is not very well appreciated in the community that we have to take into account the impacts of gradual climate change. And gradual climate change means the temperature is increasing, and despite of, or because of the increasing temperature, we can see a decline in the economic productivity, labor productivity, capital productivity, and also agricultural productivity. So this is these graphs are part of a paper which has been published 2 weeks ago in Nature, and you can see there is a kind of an optimum in temperature, an optimum which is quite favorable for economic productivity. You can see here China, US, and Brazil. So Germany is a little bit too cold, I would agree with that. China is a little bit too hot. But if you take into account these projections and aggregate these microeconometric studies into a macroeconomic assessment, you can come up with quite worrying numbers. In the poorest countries in the next few decades, you can see a decline of GDP per capita about 75%, and even in the more wealthy countries, a decline of 25%. So therefore, it is worthwhile to limit the increase of global mean temperature. But this has a very important implication. What's the most important implication? The implication is, if we want to limit the increase of global mean temperature, only a specific budget can be released into the atmosphere. The IPCC has calculated we are allowed, in order to limit the increase of global mean temperature around 2 degrees, we are allowed to release additional 1,000 gigatons. And I already told you, the already existing infrastructure and also the plans basically lead to an exhaustion of this whole global budget. Therefore, there is a strong need to find an effective short-term entry point into a climate policy. And this basically means that until 2050, we have to reduce the global emissions between 40 to 70%. This range is not driven by scientific uncertainty. It's basically all about technological uncertainty, because we need a specific cluster of technologies, which is carbon capture and storage combined with bioenergy and afforestation, which allows us to produce basically negative emissions. Now, what are the consequences for international energy and climate policy? And now this is my favorite slide. I told you that it is the best to think about climate policy to perceive the atmosphere as a limiting disposal space. And basically, the limiting disposal space is about 1,000 gigatons CO2. I would like to give you, because today I'm generous, a few hundred gigatons more. This doesn't matter too much. Why? Because we have 15,000 gigatons CO2 underground in the form of coal, oil, and gas. And admittedly, we will not extract and exploit all the gases, all the coal and oil from the ground, because there are increasing extraction costs. But even if we take into account these economic perspectives, it leads to dramatic economic consequences. If carbon capture and storage is available, 70% of coal and 1/3 of oil and gas has to remain underground. And for the sake of simplicity of this talk, carbon capture and storage means that we have an additional storage, not just the atmosphere, but also the geological underground. If this technology is not available, so then 90% of coal and 2/3 of oil and gas has to remain underground. And this graph tells you why the owners of coal, oil and gas does not feel that the Paris meeting in 3 weeks is the most brilliant idea on planet Earth. Now, what about the current prospects? Now, countries made some pledges already ahead of Paris. Are these pledges sufficient? The simple story is no. So if we are successful until 2030, this means with these pledges we could stabilize the global emissions. I have to say, I have serious doubts that these pledges are credible and the countries are really committed to provide these numbers and to implement the appropriate policy instruments and the policy measures to carry out such a climate policy. Now, here I would like to tell you one important thing, because it's nice to break walls. It's nice to have goals, but the most important thing is you need the appropriate means. What is the most appropriate mean to break down this wall? Now, the most important thing is, I already told you, is the power of the relative prices. And if we do a little bit calculation, it turns out that finance ministers around the globe spend almost 550 billion per year to subsidize fossil fuels. If we take into account just the health cost of the coal use, the International Monetary Fund comes up with a number which is 10 times higher than the 550 billions per year. If you do a little bit calculation, then we can see at average worldwide, 1 ton of CO2 is subsidized with $150. $150. If Paris would lead to a situation where we have a zero carbon price, this would be, from my point of view, a major success. But in addition to that, we have to think very carefully how an international climate treaty should look like. And here I give you my proposal. First, at an international scale, we need a minimum carbon price. This minimum carbon price should be implemented by all the member states, and they should also have then the full access to the revenues coming from this carbon pricing. Because without this carbon pricing, the coal renaissance will not stop. And the coal renaissance is not just a story about China. It's a story about India, Indonesia, Vietnam, and it is also a story about Africa. But then the question is, would Africa, a country like Ethiopia, accept a carbon minimum price? Probably not, or at least a very low one. And therefore we have to make sure that we provide transfers that the poor countries can accept a minimum price. The good news is we have already the institutions available, like the Green Climate Fund, to provide these transfers. Now, why are finance ministers so reluctant to accept a minimum carbon price? And why is King Coal still king and has a queen of subsidies, which is subsidizing coals? So, finance ministers are reluctant because they feel that carbon pricing will distort their economies. But this is not the case. We did some calculation, it turns out, with carbon pricing and the removal of fossil fuel subsidies, you can provide for 60 countries in the short term full access to clean water, to telecommunication, sanitation, and access to electricity. So, again, it's nice to have goals, but it is much more important to have means and instruments. And carbon pricing is an important instrument. It penalizes the use of fossil fuels, it incentivizes carbon-free technologies, and it provides also revenues to do something good, to provide investments which are beneficial, in particular for the poor people. Thanks.